Hello there. If you're watching this video, we're going to start talking about isolating variables. Now, this is a subskill of things that we use to help us solve system of equations. Now, when we think about isolation, it's kind of like you're all alone. No one really likes you. But for variables, it's just the all alone part. They don't have feelings or anything like that. So let's talk about what it means to isolate a variable. It's the same thing as solving for a variable, because if you think about the problems that we've done, if you say something like 2x equals 10 and you divide both sides by 2, you get x equals 5. Lo and behold, the x has become isolated. The x is all alone by itself on one side of the equal sign. And since it is isolated, we can say precisely how much it is. So when we say the phrase solve for x, that is interchangeable with saying isolate x. Or if I say solve for y, that's the same thing as saying isolate y. In other words, make it so that your equation has that variable all by itself on one side of the equation. Now let's start putting this in some other contexts and get things rolling. Goodbye me. So here would be a fantastic set of examples on isolating for x. So if we want to isolate the x variable, I would look over here and say, you know what? The x is not by itself on this side of the equal sign. I see a minus 10 right here. Oh, but I know how to make those things go away. If I use an inverse operation of plus 10, then it will disappear. So it turns out that when x is isolated, I know that x is equal to 30. Over here, we have an interesting situation. It's hard to isolate an x when there's a ton of x's. So we will combine these x's together. 4x's equal 24. But the x is still not isolated. In fact, this is a 4 times an x. So to make that times go away, I must divide both sides by an inverse operation of 4 and telling us that we have x is equal to 6. Again, x is alone, and now I know that it is 6. Similar to the last problem, but slightly different, we have still lots of x's, but they're actually on opposite sides of the equal sign. So just like we saw in our previous video, we want to make a decision. We want to say all of our x's are going to be on one side of the equal sign. I would prefer them to be over here on the left. To make that happen, I will subtract 3 x's from both sides. So let's talk about why it was a better decision to move the x's to the left. If I had moved the x's to the right, they're already over here with the 39. That's not being any more isolated, but by moving the x's to the left, there's less going on over here. So I'm one step closer to full and utter total isolation. Okay, so this is a 3x, so I will need to use an inverse operation of divide by 3. X is equal to 13. So as I was saying earlier, when we say the phrase isolate x, it's really saying solve for x. Get x all alone on one side of the equal sign. It gets interesting when we start putting in two variables. And so you can see here in this equation, we have an x on one side and we have a y on the other side. Now we actually have more than one option to isolate. I could ask you to isolate the x variable. I could also ask you, in a different color mind you, to isolate the y variable. And seeing as the numbers are affecting our x's and our y's differently, that's going to end up giving us a different feel for the equation. But remember, since we're using inverse operations, it's not actually going to change the truth of our equation. It's just going to change the way it looks. but no matter what we get, it will still be equal to what came before. So let's try putting this into some practice. Now if I want to isolate x, I see that that's just a simple little divide, because there's only one number affecting my x, and that's this 2 right here. So if I divide this by 2, I need to make sure that I divide every other piece of the other side of the equation by 2. So x is equal to 10 plus 2y. Notice I was able to simplify both of those. 20 divided by 2 is 10, 4 divided by 2 is 2, and the y is just there. Sometimes when we try this divide step, one of our numbers won't go in evenly, and it might be appropriate to leave that as a fraction. So something to just keep in mind. Now let's try the same equation, but let's isolate the y. Now when I'm looking at the y, there's two things that are affecting this. I have an inner layer of this 4, and I have an outer layer of this 20. So I'm going to need to take off that plus 20, and then I'm going to need to take off the times 4. So I can take off the plus 20 with a minus 20. Let's see that. So if I do minus 20, minus 20, I notice that these don't mix. These are not like terms. One of them has x's and the other one doesn't have x's, and that is okay. I will just write them together on the same side of the equal sign. I want to point out very calmly that sometimes when we apply inverse operations, there aren't like terms to match them up with. In that case, you very calmly write both of them together on the same side of the equal sign. Okay, but we're still not done yet. We still got to take care of this times 4, and we will do that with a divide by 4. So if I divide this y by 4, I must divide all of the other pieces on the other side of the equation by 4, isolating the y. I can tell that 20 divided by 4 is 5, but this will not go in evenly. 4 is too big. So I can leave it as 2 over 4x. If I wanted to be extra fancy, I can realize that the simplified version of that would be a half. 2 over 4 is another way of saying a half. Taking a step back, we can see that we isolated x, and we can see that we isolated y. We did this by applying inverse operations very carefully. Let's move on to isolating our variables when they are on the same side of an equal sign. So right here, this time we have x and y on the same side of the equal sign. They're buddy-buddy. The problem is if our goal is to isolate one, it's going to need to move to the other side of the equal sign. So just like last time, we're going to split it into 2 scenarios and solve those each individually. My first situation, we'll say isolate for x. So here is the original equation. And I'm going to think about all of the things which are happening to my x. This is the inner layer, the times 3, and this would be the outer layer. So again, we got a times 3, and we have a minus 4y. And I would think about how I would undo that. I will undo a minus 4y with a plus 4y to both sides. So plus 4y. Making this go away. 3x's equals 4y plus 60. Notice I did not force the 4y and the 60 together. Those are different terms. One of them has a y and one of them does not have a y. But we're still not done. I still have to undo this times 3 with a divide by 3. So when I divide by 3 here, I need to divide by everything on this side, giving me x equals 4 over 3y plus 20. One of the terms was divisible by 3 and one of the terms was not divisible by 3, so I left it as a fraction. Again, this is a fairly common happening. Do not force anything that is unnatural. 4 doesn't divide by 3 evenly. Don't start writing down numbers like 1 because that's the closest thing. Leave it as 4 over 3. That is now done. Now we are going to isolate for y. 3x minus 4y equals 60. So if I look for my inner and my outside layer, this would be my inner layer, and this would be my outside layer. This is going to be rather tricky because we're trying to think about how each of these is affected. We have this additional 3x, and you might think it's being subtracted from it, but it's not. It's actually an additional 3x. This negative 4 right here is actually being multiplied by the y. So this is a multiplication by a negative 4. So if I wanted to undo it, if I wanted to isolate it, I would have to take away 3 x's from both sides. They do not mix, so we have minus 4y equals negative 3x plus 60, and I will need to divide both sides by negative 4. So divide, divide, divide. Y equals positive 3 over 4x minus 15, and the y has been isolated. Quite honestly, this is probably one of the most abstract lessons because we've got two variables together, and what we're used to seeing with our inverse operations can look a little different when we're focusing on them at the same time. So I would highly recommend that you watch this video just one more time before you implement and try a worksheet, and please do come talk to me about what we've done. Keep in mind that the big picture is about isolating. So isolating means getting the variable all by itself. If there's only one variable, go ahead and do what you already know how to do. Use all of those inverse operations so that you can get a single variable all by itself. When there's two variables, it can get rather tricky, and usually the variable that has less going on around it is going to be much easier to isolate. So you'll notice that isolating x took a lot less work than isolating for y, and we could have predicted that because there's not so much going around the x and there's a lot going around the y. However, when the x and the y are on the same side, you're going to get a lot of work either way. So, hope this was helpful. Try watching it one more time and move on to the assignment.